All right, this is for my afternoon classes, but I'll leave it up for just an extra video on my website as well for anybody who wants to reference a couple examples we're going to do. This is primarily for my 5th and 6th period. I'm not going to be there. Well, I could be sneaking around the corner, who knows. And this will cover the very, very basics. I'm just going to hit a couple examples each. So you need to pay attention, but the good news is you can pause, rewind, and hit the definitions. But it's not too complicated today. So let's go ahead and get started, but I do want to run through the homework. Now I'm going to hit each page kind of quick because I do want to keep this video as short as possible. So if you need to look at your homework problems, hit pause. I'm not going to explain them because we're going to zip right through it. So here's the homework from yesterday. Go ahead and start checking your work. If you need to hit pause, hit pause. Okay, moving on. And you classify by angles. And isosceles, you just set them equal to each other. Now my last class didn't get too far into their homework. Hopefully you knocked it out and did pretty good honest effort on it last night. Okay, classifying by the angle measures. Next. And what we have here is you just set them equal to each other. 6x goes in the 5.4.9 times. Plug it back in to find the length of your side. Sometimes, always, never questions are my favorites. I love them. And I did some counterexamples for you. One where it's true, one where it's false. Okay, on to the harder problems. Page 276. You're dealing with isosceles. And you're going to have a lot of isosceles on your quiz and test. 6 and 9. This is one of my favorites. You have to think about this as the base angles. So that's going to be 2x also. Add all these up to set it equal to 180. Knock it out, and you get your angles. Angle A is 90. So you end up with a right isosceles, actually. Okay, moving on. 14 and 19. If you don't like fractions, just go ahead and multiply by 4. It kills them all out. I wonder if I took that one out. I don't have that handy. I think I might have changed my mind on one of these. Anyway, okay, moving on. 16. Oh, something's out of order, but that's okay. It's late. It's almost like 10 o'clock here. I had geometry and algebra 2 homework to help with my kids. They got really, really hard homework today. Okay, always, sometimes, sometimes never. And there's my counterexample. And let's go ahead and get started with the lesson. Now, these are some of the things we're going to talk about. A couple I'm only going to touch on because they're not a big deal just yet. And in the future, when they do become a big deal, I'm going to hit it again. So let's go ahead and start off with, well, something you already knew. And this is actually a theorem that can be proven. But the sum of the angles of a triangle are equal to 180. We're not going to prove that, though. Not right now, anyway. And here's something that's going to come into play much later. Not such a big deal now. It's called an auxiliary line. So you're not going to be quizzed on this, but it will come back to get you later. We can draw an auxiliary line to where these are parallel. These two lines are parallel. That creates a transversal right here. And the transversal relationship is 3 and 5 are alternate interior angles, so these are equal. And 1 and 4 are equal. And this will come in again later. And this is how we actually prove that the angles of a triangle are added up to 180 because we have a linear pair right here. All these add up to 180. Use some substitution because these are equal and these are equal to say that the triangle is equal to 180. That's going to come in for some other useful things too. I just want to tuck that back into your mind so we can come to it later. Corollaries are just fancy definitions, basically pulling out a definition from another definition. And we already knew about this. These are going to be complementary. And of course, all these are going to be 60 degrees. Okay, we talked about that yesterday, so don't need to go into it again. Now, here is a very, very big deal. We have what is called remote interior angles and our exterior angle. These two right here, given this exterior angle of 4, this is my exterior angle, okay? These are going to be my remote interior angles. And the reason this is important is because you're going to have to bear with me because this can get a little confusing. The good news is you can pause, rewind, relook, and all that other stuff. So I'm going to go ahead and call this angle 1, 2, 3, and 4. Now we've already established that the angles of a triangle add up to 180. So 3 plus 2 plus 1 is equal to 180. So 3 plus 2 plus 1 is equal to 180. That's established. This is a linear pair right here. So 3 plus 4 is equal to 180. Now look at this. This 3 and this 3. So we can say, okay, 3 plus this something right here is equal to 180. And 3 plus this something right here is equal to 180. Well, it turns out that if you're going to take a number and let's go ahead and put a number in here. We're going to call this, for simplicity's sake, I'm going to call this 50, all right? So 50, this is going to have to be 130 out here. Well, if this is 50, both of these are going to have to add up to 130. Both of these two angles will have to add up to 130. This and this have to be the same. This is a very, 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 very big deal for this chapter. 4 is equal to 1 plus 2. And that is basically your exterior angle theorem. Again, 4 is equal to 1 plus 2, these two remote interior angles. Huge deal, and here's what it is out of the book. 4 is equal to 1 plus 2. So these two guys added together equals to this 4 right here, this exterior angle. And this is how it works in problems that you may be encountering. Here we have our exterior angle of 5x minus 60, and then we have our two remote interior angles. Well, they're equal. So you just hit 5x, that's a fancy little 5, is equal to 2x plus 18. Okay? I'm going to subtract 2x on both sides, so that gives me 3x. I'm going to add 60 to both sides, so that gives me 78. And x goes into 78, well, it goes into 60 20 times, and 18 left over, so that's a 6. So 26. And to find my angle, all I do have to do is just put in a 26 here, and a 26 right here, and I get whatever these angle measurements are. Okie dokie? Next example. Now, this is the third angle theorem. Like for instance, I'm going to say this is 50 and this is 70, and we're going to call this one 50 and we'll call this one 70. Okay, so this is equal to this one, and this one, two lines, two archy things, is equal to that. It goes to follow that this angle right here, which has to be, let's see, that's 120, so this has to be 60, and this has to be 60, are going to be equal. Now just imagine if we didn't know what these were. Sound effects. I'm going to say this one is equal to here, and this one is equal to here. So if this is equal to that one, that's equal to that one, it goes to follow that this guy right here has to be equal to the other one. So that is our third angle theorem, and here it is out of the book. Okay, this angle and this angle have to be equal. Take a picture. Well, let me erase so you can get a better picture. There you go. Take a picture, as many of you do, and let's get moving on. Here's how you use it in a typical problem. So I'm going to have 6y minus 40 is equal to 4y squared because of the third angle theorem, because these two are equal, these guys are equal. So I'm just going to set this right here. I don't want red, I want purple. So we got 6y squared minus 40 is equal to 4y squared. And guess what? This is similar to this problem right here. I'm going to subtract 4y squared on both sides, so I get 2y squared. And I'm going to add 40 to both sides. 40. So y squared is equal to 20. So y is equal to radical 20. And if I'm going too fast, pause, slow, look, whatever. I want you to simplify your radicals. This is nothing more than 4 times 5. Square root of 4 is 2. 2 radical 5. QED. Okay, so let's take a look at one more example, and then I'm going to get this uploaded to YouTube and go to bed. Third angle theorem, 4x minus 32 is equal to 2x squared. So 4x squared minus 32 is equal to 2x squared. Subtract 2x on both sides, add 32 on both sides, so I get 2x squared is equal to 32. X squared is equal to 16. X is equal to plus or minus 4. Okay? And it turns out that either x works, the positive or the negative 4. So I can plug in and find my angles. So that's 16 times 2, so this guy is 32 right here. Okay? We won't be able to find the other ones, though, because we don't know what they are. That's pretty much it, guys. So here's your homework. I'll have that up on the board, too. And practice, because I'm not letting you off the hook just because I wasn't here this afternoon. I expect you to get this down, and if you have questions, hit your neighbor, call the helpline. There's tons of online resources. This entire course is online by hundreds, if not thousands, of teachers out there. Alrighty, we'll see you on Wednesday.